Hello, my dear, hello, my dear students. Welcome everyone to India's first animated live tuition. I welcome all of you to 90 Plus My Tuition app. So please do let me know, guys, if you have any concerns, queries. Turn on your camera. Get ready for a brand new session. Let me see you guys active and happy over there. I hope all of you have solved the previous question which I gave you as homework. The one last question which I gave you in the end of the previous session. I hope you do remember that. So I hope you have done the homework. Fine. So let's check out how many of you have done the homework. Let's see. Just a second, Rahul sir.
Yes.
So those who have done the homework, get it ready, get it ready. I hope you do remember the question. So those who are not there in the previous session, please do copy this homework. Yes, Rahul sir, please make me invisible just for a second, guys. Yes, everyone written the question. Okay. So I guess those who were there in the previous session, you guys will have the question already, right? So the new students who just joined today, this was the homework question which I gave for everyone. So okay. Comments coming up on my looks. So did you cut your hair? Yes, I've just adjusted it. Should I look messy with long hair and all? No, right? Fine. So I have just adjusted it. Fine. So guys, how many of you have done the homework? Raise your hands. Let me see. For my new students, don't worry. For the sessions which you missed, contact our admin team. They will be providing you with the not the Google Form link. They'll be providing you with the YouTube link of the live sessions which is recorded. All the previous sessions are recorded. So you'll be getting the link of it only if you ask, only if you request to our admin team for the sessions which you missed. And guys, one more important thing. It is not like always you can skip the session, you can take leave, you can take off, and you'll be like, yeah, next day I'll be asking the link of it and I can watch the session. No. You should have a genuine reason for it. Always don't do that. Try to attend maximum number of sessions lively. Stay over here itself. What is the advantage? What is the advantage of it? Directly you can ask me the doubts. Directly you can drop the queries in the chat box. When we are solving a particular problem, when we are solving a particular numerical problem, what will happen? Obviously when you try to solve it, you'll have some doubts, queries and all. So if you are in the session, when you are getting a doubt, you can get it cleared right away in the session itself. But if you're watching the recording, what you'll do, you'll ask to YouTube, what is the distance between the object and its image? How did we get the distance as 20 centimeters? So you can't ask that, right? So what you'll be doing? Google? No. Always, please do understand the concepts lively, please do attend the session regularly, and only please do watch the recording only if you have a genuine reason. Since you took leave or you were away, you were not able to join. If you have some concerns, please do reach out and please do watch the sessions which you missed. And for the new students, if you have any doubts during the session, raise your hands and ask me directly, or else you can drop your queries in the chat box. We have a support tutor as well. Today, Judy ma'am is assisting you guys as a support tutor. And Rahul sir is our host today. So he'll be helping us with the animations, slides, the classes happening over here. Fine. So I guess...
Hand raise.
Yeah. Who was that?
Linda.
Yes, Linda, unmute yourself. Linda, you just joined today or what? You were there in the previous class. Okay. So previous class was your first physics session, I guess. Fine. So what's your doubt, Linda? Linda, are you there? Okay. Okay, accidentally you have hand raised. Fine. So Linda, what you have to do is tilt your camera a little bit down. I can't see your face properly. Fine. Good to go. Please do reach out if you have any queries, okay? Clear? Fine.
Zainab.
Zaina, right? Zainab.
Yes.
Yes, Zainab. Raise your hands. Not raise your hands. Unmute yourself.
Yes, sir.
Zainab is like, sir, I have already hand raised. Yes. So Zainab, what's your query? Go for it.
It's like this magnification.
This magnification.
How do we find it?
How do you find magnification? Were you there in the previous session?
Yes, thank you.
You were there, right? So do you remember this particular point which we learned? Magnification is the ratio of HI to HO, where HI is the height of the image and HO is the height of the object. So if you find the ratio of HI by HO, you will get the value of magnification, that is minus V divided by minus U. Clear? Got it?
Yes, sir. Yes.
Fine. So Zainab, when we are solving some problem, when we are solving some numericals, you'll have better clarity or understanding. Got it? Still, if you are confused, please do reach out. So it's just that you didn't revise the portions which we learned in the previous session. I guess that is the thing. So please do revise all the particular concepts, topic which we have learned in the previous session. Okay? Fine. Okay, Angelina Madhu. She was there with us for the last academic year, in the last academic year as well. I do understand that. Fine. Not able to, because there is, come again, there is some software update going on. Software update won't affect your video aligner. We have the computer experts sitting over here, Jikki sir and Rahul sir. Rahul sir is like, whatever software update is happening in the background, it won't affect your camera. I hope you know that. Fine. So please try to fix it. If you still have a problem with your camera, log out and log in again. Do that. Quick. Log out and log in again. Fine. So guys, let's go ahead with this particular question. I hope all of you are thorough with the previous problem which we have discussed already. This particular problem, fine. So in this particular question, some of you were asking, sir, over here it is convex mirror, right? So for convex mirror, should we take positive value? Because in the case of convex mirror, the image is formed. In the case of convex mirror, the image is formed on the rear side, right? The image is formed on the rear side over here. So it is behind the mirror. So when we consider the Cartesian plane, it is to the right side, right? It is to the right direction. Fine. So why can't we take it as positive, or is it positive or is it negative? Some of you were confused whether we should consider the value of the focal length of convex mirror as positive or negative. So the thing is, practically if you ask me, for mirrors, we know it, right? Always we have to consider the values or the object, we are keeping it in front of the mirror, because unlike lenses, it doesn't have both sides, it just have one face, right? The other side is the rear part of it. But in the case of convex mirror, if we check out the ray diagram, or theoretically if we analyze, you know that there will not be a particular image formed in front of the mirror, isn't it? Image is formed always behind the mirror. So in that case, for numericals, you should consider the focal length value of the convex mirror as positive. How many of you have asked me this in the previous session? Some of you had a confusion, and I told you guys, you can take it as negative itself. But conventionally, generally, in the case of convex mirror, we can consider the value as positive itself. That's not wrong, or you didn't make a mistake. Got it? Got it? So, but universally, if you ask me, in general case, or what we say practically, always we'll consider in front of the mirror, right? So that is why in some textbook or in some websites, you can get to see, in some guides or something, you will get to see the focal length value of convex mirror, or for all the mirrors it will be negative. But theoretically, when we solve problems and all, or when we solve numericals, give the value of focal length of the convex mirrr as positive itself. Got it, everyone? Clear with it? Clear, everyone? Fine. Yeah, who was that sharing? Sir, it's negative, SA. No, this is 10th. Some of you are asking, sir, is this 9th? No, this is 10th grade. But Ujjwali ma'am, who is asking it is negative? Who is saying it is negative? Ansh, the focal length of a convex mirror, theoretically you should consider it as positive. Clear? Practically, if you ask me, always it's not possible, right? We won't get an image behind the mirror, practically. It just appeared to form an image behind the mirror since the rays are incidenting parallel to the principal axis. So based on the rules, we can say that the image is formed behind the mirror, or theoretically we have to consider the value of the focal length of the convex mirror as positive. Clear? And type clear or yes, or let me know if you have a doubt, or please do hand raise if still your query is not cleared. If you are still confused, do let me know. Anyone else? No, right? In the previous session when we were solving this particular problem, we got the magnification value as negative. It's not possible, right? Over here in this case, not possible, right? So we should get it, we should get behind the mirror, right? We got it as negative. Why? Since we took the value of convex mirror, focal length of convex mirror as negative, we should have taken it as positive. Clear? Fine. So I guess everyone have a clarity in this. Give me a thumbs up, everyone. For all the numericals, focal length of the convex mirror, take it as positive. Be positive. Give me a thumbs up, everyone. Give me a thumbs up if you are clear with it. Got it? For concave, we can consider it as negative, even though we consider it practically, theoretically, always will be in front of the mirror. So for concave mirror, we can consider it as negative, but for convex mirror, we have to consider it as positive. Got it? And in some guides and textbook, there will be a confusion. Not the NCERT textbook, other guides, other websites will be showing, for all the mirrors, the focal length will be negative. But there is an exceptional case in the case of convex mirror. Theoretically, in the case of convex mirror, there is an exception. Theoretically, should consider it as positive. I hope it is clear. I have mentioned this just because we are solving more problems, right? We are solving more numericals, so that you have to apply negative value, positive value now. Got it? Fine. A student wants to project the image of a candle flame on a screen 60 cm in front of a mirror by keeping the flame at a distance of 15 cm from its pole. Write the type of mirror he should use. Find the linear magnification of the image produced. What is the distance between the object and its image? So over here, I told everyone, when you get a question, try to visualize it first. So, a student wants to project the image of a candle flame. Okay, we are considering the candle flame. Got it, Rahul sir? There is a delay over here. Yeah, there is a delay with the pen. So, guys, over here, yes. Over here, what are we doing? We are trying to visualize it. We are considering a candle. So how will we get an image of a candle flame? We'll take a picture using a DSLR camera, right? No. So over here, we are considering a particular mirror. So candle is the source of light. So that is the object which we are considering. Yeah, just a second. So candle is the source of light which we are considering. Got it? So from the candle, we'll get the light. So that is the source. So we can consider the candle as the object here. Fine. A student wants to project the image of a candle flame on a screen 60 cm in front of a mirror. So in front of the mirror, we are keeping the screen. Screen means what? The area where the image will be formed. Got it? So we are keeping the screen. Let's consider it as over here. If the image is formed in front of the mirror itself, it will be a concave mirror, right, guys? Because in the case of convex mirror, do you remember? Always, still there is a delay. So always in the case of convex mirror, the image is formed behind the mirror. Got it? Only in the case of concave mirror, we'll get the image in front of the mirror, right? So what is the question? In the question is mentioned, candle flame The image of a candle flame is formed on a screen 60 centimeter in front of a mirror. Since the image is formed in front of a mirror, we can consider it as the concave mirror itself. So we are considering it as the concave mirror. Yes. So, by keeping the flame at a distance of 15 centimeter from its pole, so from the midpoint or the pole, so till the object distance or from the pole to the object, we have 15 centimeters. Look at the screen. So, write the type of mirror he should use. What can we do regarding it? Write the type of mirror he should use. So you know it, right? We have drawn the mirror already, so you know which mirror. Fine. So guys, type it down. Type your answer in the chat box. You don't have to raise your hands to answer. Type it down in the chat box. Achal, you have a query or you want to answer? If it's a query, put your thumbs down. No, not a query. Okay, you want to answer. Fine. So the type of mirror he should use is concave mirror for sure, since the image is formed in front of a mirror. So for this particular question we got the answer. Concave mirror. Now we are keeping the flame at a distance of 15 centimeter. We have marked it. So this is the object distance, and we are getting the image away from it. So suppose this is not actually 60. It will go beyond that. But for the time being, we are marking it as 60 centimeters. Got it? So now we have visualized it. Now what is the second question we need to solve? Find the linear magnification of the image produced. We need to find the linear magnification of the image produced. So guys, we are getting the image linearly, right? Linearly means straight, not curved and all. We are not keeping the object away. So that is linear magnification. It is not some complex concept and all. It's just a simple concept. Clear? Fine. So, over here is the object distance given. The object distance is given, right? Fine. Now, is the image distance given? Image distance is given. So, you know that U is the object distance. Okay? U is the object distance. Okay, I don't have to write behind. And just a second, guys. And V is the image distance. So you have the value of object distance and image distance. Find the magnification. And what is the distance between the object and its image? So you have to find that as well. So let me know the answers of the sub questions B and C. Try to solve it. I know many of you were not there in the previous session, so please try to solve it real quick. Once you are done, type down in the chat box. Once you got the answer, type it down in the chat box. Yes, Rahul sir. So once you're done, I'll come back. Please make me invisible in the meantime. Yes, this problem itself. Yes. Everyone done, right? Everyone done? Fine. Fine. I guess everyone is done with it. Everyone done with the problem, right? Easy. I'm not giving much time just because we have solved this already in the previous session. Isn't it? Fine. So let's try to solve it. Who got the answer already? Who is gonna help me out? Anyone? Unmute Rihan. Hi Rihan. Unmute yourself. Rihan P. Shahjahan. Yes. Unmute Rihan. Raise your hands. Rihan is like, sir, please don't call my name. Judy ma'am, so Rihan already. Yes, third, yeah, down there. Yes, Rihan. Rihan, do you know how to solve this?
I know.
You know it, right? Fine. So let me know the magnification formula.
It's minus V by U is equal to H1 by H4.
Minus V by U is equal H1? H1?
HI.
HI. What is HI?
Height of the image.
Height of the image, not H1, N1 and all. That's a virus. So HI divided by
Height of the object. HO.
just a second, guys. HI divided by HO, right? Fine. So what are we doing? We are considering the values. So let me know what is V.
60.
V is the image distance, right? It is given 60 centimeter. So should I consider positive V or negative V?
Negative.
Negative V. Why negative V? Negative 60?
Because that's what it says in the formula.
In the formula. What formula? Why we are considering it as negative 60? Based on what?
The
New Cartesian sign convention. Rihan is like, I know it, but I don't forget the term. So, based on new Cartesian sign convention, from the right to the left, from the origin, we need to consider the values as negative. I hope all of you do remember it. Do you remember, guys? From the origin to the left, it is negative. From the origin to the right, it is positive. Clear? So we are considering from the origin to the left the value of the image distance as negative 60 centimeters. Now what about the object distance, Rihan?
15 centimeter.
It is positive 15 or negative 15?
Positive.
Positive 15, right? Where are we keeping the object?
Negative.
In front of the mirror. Why did you say positive? So once we solve this problem, once we solve this numerical, no, what you have to write? In front of the concave mirror, the value will always be negative. Clear? Clear, Rihan? How many times? 5 times. Okay? In front of a concave mirror, the value will always be negative. Got it? I hope you will do it. Fine. So once we are done with the problem, I'll ask you, right? Do it right away. Fine. So we are considering the value of object distance as minus 15 centimeters. Now, so as to find magnification, we'll apply these values, right? So minus V means, how will we apply this value? Minus V means minus of minus 60, right? Rihan, are you there? Rihan ran away or what? Okay, now we'll call Achal. Achal wants to answer. Rihan, you write the imposition. Quick. Achal, unmute yourself.
Hello? Yes, sir.
So Achal, we are considering the value of magnification as minus of minus 60 divided by minus 15. Is this correct?
Yeah.
Perfect, right? Why? Because the equation of magnification says that it is minus V by U. Here, the image distance is minus 60. So minus of minus 60. So that will be
Minus 4.
minus of minus 60 means plus 60, right?
Yeah. When you simplify it, it will be minus 4.
Yeah, 60 divided by minus 15, isn't it?
Yeah.
60 divided by minus 15. So that will be equal to minus 4, right?
Yeah,
Minus 4 is the magnification value. So did we get the answer for the second question? Achal, did we get the answer for the second question?
Yes, sir.
Fine. Now, what is the third question? What is the distance between the object and its image? What is the distance between the object and its image?
That's 60 minus 15. 45.
So as to find the distance between the object and the image, we can easily find it 60 minus 15. So we'll get the image, get the distance. So for C part, we can easily do it. 60 minus 15, how much it is?
45.
45 centimeter is the distance between the image and the object. And if we get the magnification value as negative, what about the image formed? What about the nature of it? If the magnification is negative. Achal, are you there? Achal ran away over. Achal, if the magnification value is negative, the image form will be real and inverted. For real images, magnification will be negative. I hope you guys remember it. We have learned this already in the previous session. Got it? So we are applying it directly. For real images, the magnification will be negative. Please don't forget. Got it? So I hope you have understood this particular problem, this particular question. It's very easy, right? Easy. B part or the second part of the question, C part or the last part of the question. Directly we are subtracting the object distance and the image distance values, so we'll get the difference or the distance between them. So that is 45 centimeter. So when you saw the question, you felt it like, okay, big tough question, right? Now is it easy? Easy, right? Unmute Mohammed. Who was that? Nurul. Yes, Mohammed Nurul, what's your doubt? Go for it.
So shouldn't be minus 60 minus 15?
Shouldn't it be minus 60 minus 15? So, can you see the equation or formula of magnification?
So they're asking distance between object and the image, right?
Okay, you are asking about the C part.
Yeah.
Okay, so you are asking, should we consider minus 60 minus 15, right?
Yeah.
No.
60 minus
It is, these values we are considering only in the case of magnification or considering the object distance and image distance only when we are applying it. But in this case, what are we doing? We need to find out the distance between, over here, imagine this is the image. Over here we have the image at 60 centimeters. We have the object at 15 centimeters. So we have to calculate this particular distance value. Got it? So we can apply the logic over there. You don't have to consider, since the image is formed in front of the mirror, it is minus 60. Because we are not subtracting the image distance and object distance directly by applying the signs and all. What are we doing? We are just applying the logic over here. We are subtracting the image distance minus the object distance, so that we'll get the distance between them. Practically think over here. 15 centimeter and 60 centimeter. What will be the gap between 15 centimeter and 60 centimeter? It will be 45. Clear? Got it, Nurul?
Yes, I got it.
Yeah. When we are applying the values in the equation and all the formulas, like for mirror equation, for magnification, you have to apply, you have to give the sign of it. But over here, it's not like we are not considering sign. We are considering the actual logical application of it. Why? To find the distance between the object and its image. We know the object is at 15 centimeter. We know the image is at 60 centimeter. So we are not applying any formulas over here. So if the object is at 15 and the image is at 60, the distance between the object and image will be 45. Clear, everyone? We're just applying the normal mathematics. Just subtracting the value of image distance minus the value of the object distance. Clear, everyone? Give me a thumbs up if it's clear. Give me a thumbs up if it's clear for everyone. Let me see. Those who are not responding, you will be in the waiting room. Some of my students are like, sir, I'm neutral. I didn't understand, or I got it. I got everything clearly, or I'm in the middle, so a little bit confused. Guys, you can ask straight. Fine. Clear, I guess. Clear for everyone, I guess. Fine. So can we go ahead, guys? Can we go ahead? Fine. So next question, guys. This is important. This question was asked in Cbse 2020. Cbse 2020 was asked. So let's try to solve it. An object 4 cm in size is placed 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of the image. So the question is, we need to find the nature and the size of the image. Got it? So also we need to find at what distance from the mirror should a screen be placed in order to obtain a sharp image. So if there is a question, at what distance from the mirror should a screen be placed in order to obtain a sharp image? What does that mean? What does that mean? Who will answer me? What does that mean if there is a question? At what distance we should keep the screen to get a sharp image? So what is that particular distance? Anakha, Srijit, unmute yourself. If there is a question on top, yes. If there is a question, if there is a question, at what distance from the mirror should a screen be placed in order to obtain a sharp image? So Anaka, why do we use a screen? Anaka,
Like
to get the image on it, right? To get the image fall on it, right? Yeah. So at what distance from the mirror should a screen be placed in order to obtain a sharp image? What does that statement means? So based on this statement, what distance should I find?
the mirror, the distance of the mirror and the object.
Not at all. At what distance from the mirror should a screen be placed in order to obtain a sharp image? What is V, Anaka?
The object distance and image distance you have to find. The object distance.
What is V based on mirror formula?
The object distance.
V is object distance, right, Anaka?
No, V is image distance.
V is the image distance. So if there is a question, at what distance from the mirror should a screen be placed in order to obtain a sharp image? So this statement indirectly says that we need to find out the image distance. Clear? It is an indirect question. So you'll be saying, okay, at what distance should a screen be placed? So you guys will be confused. Oh God, we didn't learn to find the distance of screen. But actually, what is it? If we are keeping a screen to obtain a sharp image, that is the actual image distance. Got it, Anagha? Next time when Anagha gets such questions for exams, she'll be like, I won't forget it in my entire life. Since was teasing me, since I made a mistake. Now, is it clear, Anagha? Any doubts? So, this question states that you have to find the image distance first. Then we have to find the nature and size of the image. So, anyone hand raised? So guys, try to solve it first, then I'll do it for you. I guess I don't have to go invisible because everyone will solve it very easily, isn't it? So, don't go invisible. We'll solve it right away. Yeah. Devanarayan, go for it. What's your doubt? Come again? I didn't get your question.
Should we use mirror equation for this question?
Should we use mirror equation for the question? For sure. You need to find the image distance, right?
I'm just asking.
Yeah.
Every time I say a question, it's like changing it so complex.
Every time? Every time? Devanarayan, you are muted, I guess. Yes, Devanarayan. Every time?
Every time I say a question like this, it's like getting more complex.
Getting more complex. Okay, since I'm not able to hear it properly, right?
Yeah.
Yeah. So it's just that your voice or your mic has some problem, I guess. It comes with some extra bass over here. Got it? So Devanarayan,
Yeah.
you just asked, should we use the mirror equation, right?
Yeah.
So in the question, did you understand that we need to find the image distance when I was explaining it to Anagha? You got it, right? Fine. So as to get the image distance, obviously you have to use the mirror equation. Without that, do you have any other option? Over here we can't use the magnification formula now because we don't know the height of the image or height of the object. Got it? So here obviously you have to use the mirror equation. Clear? Fine. So tilt your camera. Is it clear there, Narayanan? Yeah. Tilt your camera a little bit down. I can only see half of your face. Fine. Devanarayanan is like happy. So Devanarayanan, if you find it tough to ask what you meant to, what you have to do, drop it down the chat box. Don't worry. Sir, will we discuss the questions of 2022 board exam physics for sure? 2022-23 academic years question we'll discuss. Don't worry. Not now. At the end of the chapter, not at the end of the chapter, at the end of all chapters, we'll have a marathon session, we'll have a previous year question discussion session, we'll do that, don't worry. So, in the meantime, what I'm doing, I'm just adding some important previous year questions in between, that's it. So, it's not like we'll be skipping the previous year questions, obviously we'll give importance to the previous year questions itself. Yes, Sridaya, right? Yes, Sridhya, let me know what's your doubt, what's your concern?
The sharp.
Come again?
What's the meaning of sharp image?
Sharp image means focused image. Focused image. Focused image. We are getting a focused, proper image, not something which is scattered or unclear and all. Got it? That is meant by a sharp image. So, if there is a statement like where should we keep the screen to obtain a sharp image, it means that we'll get a proper image over there. So that is the image distance we need to consider. Sharp image means focused, clear image. It's not like scattered or blurry. Got it, Sridhya?
So why should we use that that equation, mirror equation?
To get the image distance. To get the image distance. It's not mandatory. If you can apply the height of the object distance, height of the object and other values and get the image distance, it's fine. You can use the magnification formula as well. Got it? Over here, if you are confused, since the height of the object is given, so you'll be thinking, oh God, should I apply the magnification formula? You can do it that way as well. Clear? Either you can use the mirror equation or else you can use the magnification formula. Got it? Sridhya? Yeah, it's up to you. We can do the simplest way. Don't worry. Yes. You provide competency based questions. Yes, I do. Competency based questions will come your way. Don't worry. Over here, all the numericals which we are considering is not something randomly which is given in your textbook or something which is given somewhere else. No, we are researching on the important previous year questions or the important questions to stress. We are filtering it, so we are just providing the different type of questions. So you guys will get to familiarize with different types of it. Got it? And mostly we'll be considering the NCERT questions itself just because for board exams and public exams, NCERT questions are the core, right? So that is the reason. So how many of you got the answer? How many of you got the answer? It'll be easy if you are using the mirror formula, right? Because to apply the magnification formula and get the answer would be tough, right? Because we don't know the image distance. Also, has to get the image distance, if you are using the mirror formula, what you'll be doing? Minus V by U is equal to HI divided by HO, isn't it? So we have the value of HI is there. We have the value of, okay, is placed at, an object is placed at 25 centimeter. So we have the value of U is there. HI and U is there. Do we have HO? No, right? Do we have image distance? No. So it'll be tough if we are applying magnification formula and mute Sridhya. Sridhya, understood why did I say it's better if you use the mirror equation? Now you understood why should we use the mirror formula? Fine. Sridhya is giving me a thumbs up. So Leora D'Souza got the answer and she wants to help me, I guess. Hi Leora.
Hi, sir.
So Liara, can we solve this? Any doubts?
No.
No. Fine. So we are considering the object, the height of the object distance, the focal length value. We have these three values. Okay. So based on it, first question is we need to find the image distance, right? So as to find the image distance, which formula we'll use?
We'll use the mirror formula.
We'll use the mirror formula. 1 by f is equal to
1 by v minus 1 by v plus 1 by u.
1 by v plus 1 by u, or 1 by u plus 1 by v. Fine. So before we go, let's take down the values which is given in the question itself. So HO is given, that is 4 centimeters. Then what else we have over here? We have the focal length 15 centimeter. Yeah. So why is it minus 15? Focal length of the concave mirror will be on the left side, so we need to consider minus from the origin to the left side, or from right to left from the origin based on the Cartesian sign convention, negative. Now, what is the object distance? U minus 25. Why it is minus? Why it is negative? Object is in the left of the concave mirror, so in the case of concave mirror, always, please don't forget it, always will be negative value, because the image and the object will always be in front of the mirror, right? Only there is one single exceptional case, that is when we keep the object between f and p, or f and the origin, or f and the point. Fine. Now 1 by f is equal to 1 by v plus 1 by u. So based on it, how can we rearrange? We need to get the image distance, right? 1 by v is equal to 1 by f minus 1 by u. Got it? So we'll be using it. Now we can apply the values. 1 by v is equal to 1 by f.
Minus 15.
1 by f is minus 15. That is minus 1 by minus 25. Fine. So how will we solve this, Leora? Did you rearrange the equation? 1 by v is equal to 1 by f minus 1 by u. You did, right?
Yes, sir.
Fine. So this equation we can rearrange it like, we can cross multiply, right? 1 into u minus 1 into f divided by f minus u. Can we do that? F into u, right? Yeah. So as to get the LCM, what we'll do? We'll write it like u minus f divided by u into f. Isn't it? So 1 by v is equal to, okay, we'll write it clearly. Tell sir. Oh God. So just a second, guys. 1 by v is equal to u minus f divided by u into f. Oh God. Perfect. Fine. Now, so as to find out the image distance v, what we'll do? We'll write v is equal to, we can take the reciprocal of it, right, to get v. So, yes. So, we got the equation 1 by v is equal to u minus f divided by u into f. So from this we can write v is equal to u into f divided by Leora?
U minus f.
U minus f. Fine. So let's apply the values. So what is u? It is minus 15, right?
Yes.
Minus 15 into minus, okay. U is minus 25, Leora.
Minus 25.
Anyways, it will be the same multiplication, right? Minus 15 into minus 25, isn't it? Then u minus f. For subtraction, we should give it perfectly. So for u minus f, what we will do? Minus 25 minus 15. Minus of minus 15. Got it? So how much we will get when we multiply minus 15 into minus 25?
You get 375.
375. Positive or negative?
Positive.
Positive. So 375 divided by minus 25. Minus of minus 15 means what?
plus 15.
Plus 15. Very good. Minus 25 plus 15 means how much?
Get 10.
10.
Minus 10.
Yeah. So we'll get, okay, this will be minus 10. Minus 25 plus 15, we'll get it as minus 10. So 375 divided by minus 10, what is the value?
37.
Minus
Minus 37.5.
37.5 centimeters is the image distance that is in front of the mirror itself. That is why we got it as minus or negative in the case of concave mirror. Got it? So from the origin to the left hand side. Now, what about the nature and the size of the image? Leora, what about the nature first?
The nature is real and inverted.
The nature will be real and inverted. Why? Since we got the value as, since we got the image distance as negative, right?
Yes.
We'll get real images for okay, one second. If we get the images formed in the same side of the object, the height, okay, height will be negative, and also if we are getting the image to the left hand side, can you see over here, in the case of concave mirror, always, just in one exceptional cases, that is between P and F, always, since the image is formed in front of the mirror, always, what about its nature? Real and inverted.
Example.
No.
No.
Exam is there. Yeah. So guys, over here, the nature of the image, in the case of concave mirror, always real and inverted, right? So why it is real and inverted? Always we will get the image in front of the mirror. Just exceptional of this one single case. That's it. Remaining in all other cases, remaining 5 cases, we'll have the image and the object in front of the mirror itself. So always it is negative, and the nature of the image will always be real and inverted. Got it? Fine. Now we understood that. Now we got it as the nature of the image as nature as real and inverted. Fine. Now, what about the size of the image? Leora, how will we get the size of the image?
We can use the magnification formula.
We can use the magnification formula. Very good. Why? Only if you use the magnification formula, we can obtain, okay, not the height of the object, height of the image, right? Got it? And some of you will be saying, sir, we can directly apply the value of object distance and image distance to find the magnification formula. That is also possible. And also you can apply the equation also. We'll try to solve it by using the equation directly. Then only you will get marks for exams, right? If you say, sir, I thought logically, so image distance is minus 37.5 divided by the object distance minus 25, and when I did it, I got the value. You got the magnification, right? You won't get the height of the image. So as to get the height of the image, we need to use the magnification formula. HI divided by HO is equal to minus V by U. So from this, so as to find the height of the image, what you have to do? You have to take this HO to the other hand, right? Yeah. So you have to take it to the right hand side. So HI, that is the height of the image, is equal to minus V by U into HO, that is the height of the object. Got it? Now.
So, hand raise.
Yes.
Shaniel.
Shaniel, what's your doubt? Shaniel, unmute yourself. Shaniel, are you there? Unmute yourself, Shaniel.
Yeah.
What's your doubt, Shaniel?
I'm not able to understand the question.
You didn't understand the question?
No, to understand, I couldn't understand properly.
Okay. So initially, did I discuss the question before solving it?
Yeah.
Why you didn't ask that time?
I was supposed to ask.
You were supposed to ask that time, not now when we are solving it. Anyways, I'll let you know. So, Shaniel, basically what are we doing? We are considering an object Object where? In front of the concave mirror, right? Can you read the question? First we'll read the question. An object 4 cm in size is placed at 25 cm in front of a concave mirror. We're considering a concave mirror, we're keeping an object in front of it. Got it? Okay. Is this your first physics session, Shaniel? No. You were there in my previous session, right? So, did we learn the Cartesian sign convention? Do you remember the new Cartesian sign convention?
What's that?
Cartesian sign convention. Some of you are giving the answers in chat box. Yes, do you remember the Cartesian sign convention, Shaniel?
No.
No, right? Then how will you understand? So, the Cartesian sign convention should be there in your mind, Shaniel. This is the first warning I am giving you without revising. If you are coming to me, sir, I didn't get it, how we are considering negative. The revision should be there. That is why I tell you guys. Guys, you should know what we have learned in the previous session. If you have missed it, do watch the recording. Got it? So, Shaniel, based on the Cartesian sign convention in front of the mirror, in the case of concave and convex always, what will you consider? We'll consider the value as negative. Can you see over here?
Yeah.
Is this the front side of the mirror?
Yes.
Is this the rear side of the mirror?
Yes.
Yeah. So, in the case of the front side of the mirror, always from the origin to the left, it is negative. From the origin to the right, it is positive. Were you there when I was explaining this? Were there, right? Yeah.
Yeah.
Fine. So, based on that, from the question, we understand that if we are keeping the object, in front of the mirror, the value of the object distance will be negative. Got it? So, we'll consider the value of object distance as positive or negative.
Positive?
We'll consider the object distance as positive.
No, negative.
Why negative? Why negative? Why it is negative, Shaniel?
Because it's concerned with the left-hand side.
It is on the left hand side. The image is formed in front of the mirror. So we'll consider the object distance as negative 25. So do you know that u is the object distance?
Yeah.
Then what about, how will we denote the image distance? With which variable generally? Conventionally? Shaniel, for image distance, what we'll write? Which variable we'll use?
1 by f equals to 1 by...
That is the equation. For object distance, we used u. The letter u we used. Which letter we'll use for image distance? W. Z. Which letter? A for apple, B for ball, C for cat. Which one?
For image is I.
For image, we'll use the letter I. Who is spamming the chat box? Stop spamming. Stop spamming. Who was that?
Say.
Zaid, stop it. Fine. So Shamil says that for image distance we'll use I. Shaniel, right? Shaniel. It'll be V. So you're standing on my high tolerance level. That's why I tell you, when you are in the previous session, you should focus. You don't even know which variable we will use for image distance. So it's just because you didn't revise what we have learned. So we'll be using V for image distance. Please don't forget it, Shaniel. Clear? Yeah. So over here, do we have the image distance value in the question?
No.
No. So the question is, at what distance from the mirror should a screen be placed to obtain a sharp image? So this statement says that we need to find out what distance? The image distance. Because on a screen itself we'll get the image, right? On a screen we'll be focusing the image, we'll be getting a sharp image on screen. So the distance where we should keep the screen is the image distance. So the question is, at what distance from the mirror should a screen be placed in order to obtain a sharp image? Got it, Shaniel?
Yes, sir.
Understood the question? Now the second and next part of it is, find the nature and the size of the image. When we are getting a particular image, it will have a particular nature. Like what? Like vertical and erect or real and inverted. Got it? No, to as to find the size of the image, we have the magnification formula. Do you remember the magnification formula?
Yes.
You do, right? And you don't remember the image distance and object distance variables. In the magnification formula, we are using it, right? Minus V by U is equal to SI by SO. What is SI, Shaniel?
HI is the ratio.
HI to HO is the ratio. HI is the height of the image. Shaniel.
HO is the height of the object.
HO is the height of the object. So O here. So as to find the size of the image, we need to find out the height of the image. So that will be the size of it. Clear? Got it?
Yes, sir.
So O here. Did you understand the question now?
Yeah.
Fine. So first, when you get the question, try to visualize it first in your mind. Got it?
Yes, sir.
Yeah. So Ryan is like, sir, relax. It's okay. Chanel is the first warning for you. Without revising, no doubt clearance. Clear for everyone? If you're not revising, what is the point of explaining everything from the beginning of the chapter? Do you really think we'll go ahead? Not possible, right? That's why I tell every day, you guys should cooperate when I'm teaching something, when I'm getting to a new session. Why I'm consuming a lot of time for one single problem? What is the reason for it? I want all of you to understand in the best possible way. It's not just, okay, for Rihan it's clear, so I'll go ahead. No, there will be students who didn't understand. You can ask. But it should not be like, sir, I didn't know, or I didn't understand the image distance, I didn't understand V, I didn't understand U. The basic things why you're lacking, just because you didn't revise what you have learned. Everyone can listen and learn right away, but later on you will forget. Why? Since you didn't revise. So it's important and mandatory. It's not like you can't ask doubts, you can ask, you feel free to ask, but you should revise, you should have the concepts with you. If you have any doubts in the concepts, when I'm teaching it, you can ask, sir, I didn't understand. How will we consider the equation of magnification? How do we consider the HI and HO? You can ask that. But not when we are solving it, not when we are applying it. If you are new, I can understand. Sir, I just joined today. I'm not aware of any equation or formula. Can you give me a gist or just a brief explanation of it? I can do that. Got it? So for such things, what you have to do? For such things, always, if you feel like if you have a doubt or if you feel like you need a detailed explanation before joining the session, please do watch the recording of it. Contact our admin team so that you will get the detailed explanation of the sessions which you missed. Got it, everyone? Fine. So who was that helping me? Leora, right? So Leora, we are applying the equation HI is equal to minus V by U into HO. So for Shaniel, if you didn't understand this particular formula, 1 by V is equal to U minus F divided by U into F. We are deriving it from the mirror equation. So from the mirror equation, we have 1 by F is equal to 1 by U plus 1 by V. So in the particular question, we got it as, so as to find 1 by V, we got the equation as 1 by F minus 1 by U. So F and U is not the same, right? Different variables. So we need to find the LCM. So I hope everyone knows the basic mathematics. So as to find the LCM, what you'll do? You'll cross multiply it, right? So 1 into U minus will be 1 into U minus 1 into F divided by U into F. Guys, we have discussed this already in the previous session. I hope you remember it. Got it? So 1 into U minus 1 into F divided by U into F. So this particular equation we can write it as, so as to find if we take the reciprocal of 1 by V, V will come in the numerator and 1 will be in the numerator, right? So V divided by 1 is V itself. So V is equal to, we'll take the reciprocal of this, that will be U into F divided by U minus F. Why it is U minus F? Because 1 into U minus 1 into F is U minus F. Got it? I hope it is clear. So what are we doing? We are considering that equation over here. Now we are applying the values. Minus 25 and F that is the focal length is minus 15. It is given the question itself. Why we are taking it as negative 15? Just because the focus of the concave mirror will be in front of the mirror. That is from the origin to the left. So that is why we are considering the focal length value as negative. Unmute Shaniel. Shaniel, is it clear till now? Please be honest. Is it clear till now? Unmute yourself.
Yes, sir.
So Shaniel, ask it right away. Got it? If you have a doubt, ask it, sir. Why did we take the value of focal length as minus 15? You can ask. Not later on. When I go to the 10th problem, don't ask, sir. In the second problem, why F is negative 15? You should ask it right away. Clear, Shaniel? From future, I expect more doubts from you. Instantaneous doubts directly when we are discussing it. Not later on. Clear, Shaniel?
Yes, sir.
Fine. So over here we are considering the focal length value as negative, the object distance as negative, and we are applying the values. Then we are getting the image distance value as negative 37.5. Why is negative? In front of the mirror. Since the image distance is negative, the nature of it will be real and inverted. The nature will be real and inverted. So please don't forget it. So the nature of the image will be real and inverted. Fine. Now, HI is equal to, unmute Leora. Leora is like, sir, this is not fair. I was about to answer. You made me wait for 10 minutes. Leora, just consider this as you are having a better clarity of the concept. When I am explaining or supporting someone else, it's not just for Leora, for all of my students who are waiting with the answer already. Sir, you are lagging. Sir, the session is boring. Guys, it's just that you're getting it. You're getting it in a better way. You'll have a better clarity when I'm explaining someone's doubt. So everyone will have doubts, right? Imagine, since I feel like everyone, other students will get bored if I stop clearing doubt. Will it be useful for you guys? No, right? Everyone will have doubts. So consider it as normal. Focus over here. When I'm explaining some doubts, you are having a better clarity of the concept. So for exams and all, it will be easy for you to solve the problems. In your mind, the concept will be registered if you are hearing it multiple times. It should not be like, okay, when I'm hearing it multiple times, I'll sleep. No. You're having a better clarity of it. Got it? Leora is like, no sir, I didn't sleep. I'm happy. Good to go. Yes. So Leora, HI is equal to, what is minus V? Minus of?
Minus of
Minus
minus 37.5.
of minus 37.5 divided by U. So what is U?
Minus 25.
Minus 25 into HO. What is the height of the object from the question? What is it? 4. So minus of minus 37.5 will be 37.5 divided by minus 25 into 4. Yes. Now, when we do the calculation, how much is the value we are getting?
Minus 1.5 into 4.
Minus 1.5 into 4. Sure?
Yes, sir.
Fine. HI is equal to minus 1.5 into 4. Now, what is height of the image? Final answer. Minus 1.5 into 4. 37.5 divided by minus 25 will be minus 1.5, I guess. Fine. Calculation would be perfect, right, Leora? Fine. So minus 1.5 into 4. How much we'll get?
Minus 6 centimeters.
Minus 6 centimeter. Minus 6 centimeter is the image distance. So guys, if we get the image distance, can we find the size? Can we find the nature of size? So, Leora, if the object distance is 4 and the image distance is minus 6, did the image distance diminished or enlarged? Did it diminish or enlarge? Come again?
That was the height of the image.
This is the height of the image, right? Yeah, that I'm saying. That is what I'm saying. So what about the size of the image? Size means what? The height of it, right? Obviously. Yeah.
You just said the distance.
Okay, I said distance. Fine. I meant to say height of the image. Fine. Anyways. So Leora, what about the size of the image? What will be the difference if we are considering the height of the object as 4 and the height of the image as -6? Is it enlarged or diminished? It is enlarged, right? Leora is saying the height of the image is enlarged since it is 6 and the height of the object was 4. Unmute Leora. Unmuted, right? Leora, -6. Do you think -6 is greater than 4?
No, but like according to the Cartesian sign.
Come again.
The Cartesian plane.
Based on the Cartesian sign convention. The image will be real and inverted, right? We got it already, nature. Since it is an inverted image, we are getting the value as negative. -6. So, over here, in the case of what we say, concave mirror. The case of concave mirror, in which case we are getting an enlarged image. Between C and F, or at F it will be highly enlarged. So over here, the object distance, over here, based on the question, the object distance was 4. So we'll consider it like this, positive value, but the image will be real and inverted, right? So we'll consider it as negative value. So over here, if we consider the size of the image, we can consider it as enlarged. Why? Since it is -6. So -6 will be a greater value compared to that of 4, right? Fine. Very good, Leora. So guys, any doubt, any concerns, queries?
Sridhya.
Yes, Sridhya, unmute yourself.
Sir, see for this image distance, as it is on the poster side, won't it be changing to positive as we got the value as negative?
As we got the value of?
The image distance as negative, shouldn't it be converted to positive?
Shouldn't it be converted to positive? Where?
So the image distance.
Image distance, why should we consider it as positive?
Because it is in the right side. So
It is in the right side for concave mirrors. Always in the left side, right? So over here, focal length is 15. The object distance is 25. So obviously it will be beyond F. Obviously it will be like beyond F. It will not be within F and O. Only if it's F and P, if it's between F and P or F and O, in the case of concave mirror, only in that case we'll get the image behind the mirror or positive. Got it? Only in this case. In all other cases, we'll get in front of the mirror, so it will be negative. Clear?
yes.
Yeah, fine. So clear with this problem, everyone? Any doubts, any queries, concerns?
That's it.
So can you explain again how the magnification is enlarged?
Because the height of the image is 6, right? Because since the height of the object was 4 and the height of the image is 6.
It's -6, right?
But it is the sign. It is a sign. It is a sign for since the image is real and inverted. For inverted image, we'll get -6. You don't have to compare the values. Got it? You have to compare the height of it, the numerical value of it, not the sign. Clear?
Okay.
Yeah. Since it is real and inverted image, we are getting the height value as negative. So one second, I'll give you a clarity for this. Height of the image is negative for real images. Do you copy that? Unmute Achal. So based on these rules, you can understand why we have considered as enlarged. Clear?
Yes, sir.
Fine. So over here, if you're considering the object between C and F. So guys, unmute Achal. Achal, I'll give you a better clarity for this. Achal, from the question itself you can understand. So Achal, suppose I'm drawing the ray diagram. Guys, can I rub this? Everyone written? Can you clear this? Fine. So, Achal, the object is placed 25 centimeter, concave mirror, right? I'm drawing a concave mirror. So object is placed at 25 centimeters. Okay, object is at 25 centimeters. Okay, suppose this is 25 centimeters. Now the focal length is at 15, right? F is at 15. Achal, are you there? Fine. So if F is at 15 centimeters, where will we have C, center of curvature? C is equal to 2F, right? Do you know that? C is equal to 2F.
Yeah.
So center of curvature will be at 30, right? If F is at 15, center of curvature will be at 30. Isn't it? Achal, did you get it?
Yes, sir.
Yeah. Now where are we keeping the object? Where are we keeping the object between? We're keeping the object between
C and F.
C and F. So we are keeping the object between C and F. Now, based on our learnings, that is the image formation, if the object is between C and F, what about the nature of the image or size of the image?
Enlarged.
Enlarged, right? Now is it clear? Got it?
Yes, sir.
If you're thorough with the image formation, that is why I told you when I was explaining this particular image formation is important. You have to register it in your mind. When you know from the question itself, if the object is between C and F, practically if you think, if it's between C and F, obviously the size of the image will be enlarged. Clear, Achal?
Yes, sir.
Fine. Very good. Now we'll move on to the next question. I hope everyone is done with this. Clear for everyone? Fine. So let's go ahead. So a new problem, new numerical feels like a new challenge for everyone, right? Everyone is like, oh God, now we are going to fight with this. So guys, if you have any doubt, ask it right away, no? Later on, if you ask me, remaining students will be like, sir, A, B, C, D, A for apple, B for ball, we know it already. Everyone will be making faces. So boring, sir, please don't go ahead like this. I do understand, guys, I do understand that. So when we are explaining something, when I am giving you, sir, students, this is how you solve it. So you can say, sir, how did we get this value? What, sir, why is it inverted? Why is it enlarged? You can ask that, but not later on. An object of height, so first when you get the question, try to visualize. An object of height 6 cm is placed at a distance of 15 cm from a concave mirror of focal length 10 cm. Find the position, nature and height of an image or height of the image. You have to find the position, nature and height of the image. So if you have to find the position of the image, you have to find the image distance. Nature and height, so as to find the height of the image, we need to apply the magnification formula, that is the ratio of HI by HO is equal to minus V by U. So the object distance is already given, right? Object is placed at 15 cm. So we have to find the image distance using the mirror formula. So for the mirror formula, we need the focal length, right? Focal length is also given. Got it? Now, it is mentioned as concave mirror, then Dhruv will be telling me, Dhruv, if it's a concave mirror, will be, yes, not on top of that, yes. So Dhruv, if it's a concave mirror, what about the focal length? We should consider it as 10 cm or negative 10 cm. Dhruv.
Negative.
Negative 10 cm, why?
Because of the coordinate.
Because of the Cartesian system or the coordinate system. A new Cartesian sign convention, we have learned it already. For concave mirror, it is negative. For focal length, it will be in front of the mirror. Very good, Dhruv. Now, Now, the object distance is given as 15 centimeter. Guys, we should consider it as negative or positive. Who will be helping me out? Unmute the other Dhruv. We have Dhruv square, right? Dhruv Dilip and Dhruv Choban Putra. Hi Dhruv Dilip. Yes. So Dhruv, what should we consider about? How should we consider about the sign of the object distance? We should consider as negative 15 or positive 15.
Sir, negative U.
Negative U or negative 15. Why it is negative?
Negative 15.
Why can't it be positive?
Sir, because it's a concave mirror.
In the case of concave mirror, image the object will be kept in front of the mirror, right? Always. So that will be unmute Dhruv. Dhruv is like, sir, I have answered, right? I'll mute. So Dhruv, in the case of concave mirror, if the object is in front of the mirror, why should we consider negative?
Because it's on the
Left side. So Cartesian sign convention, from the origin to the left, it will be negative. You know it, right, Dhruv?
Yes, sir.
Fine, very good. So F is minus 10 centimeters, U is minus 15 centimeters. So we have the focal length, we have the object distance, and we have the object height, right? Height of the object H also we have. We can write it over here. 6 centimeters. Okay, not 6 meters, 6 centimeters. Just a second. So guys, once you're done, let me know. I'm not going invisible. I hope everyone can do it in fraction of seconds, right? Easy. So let's go ahead, guys. So we'll use the mirror formula, right? So as to find the image distance, 1 by F is equal to 1 by U plus 1 by V. Isn't it? So from this, to get the value of V, we'll use 1 by V is equal to 1 by F minus 1 by U. So from this formula, we can write 1 by V is equal to U minus F divided by U into F, isn't it? So if we find the reciprocal of it, we can write V is equal to U into F divided by U minus F. Can we do it, guys? We have discussed this already, right? Fine. So what we'll be doing, we'll be applying the values. U is, over here the U is minus 15 into the focal length, that is minus 10, divided by U minus F, that is minus 15 minus of minus 10. Minus 15 minus 10. Got it? So minus 15 into minus 10, how much? 15 to 10, how much? Everyone knows, right? 150. So minus 15 to minus 10 means positive 150, because negative into negative, divided by minus 15 minus of minus 10 means what? Minus 15 plus 10, isn't it? So minus 15 plus 10 will be minus 5 or negative 5, isn't it? So 150 divided by minus 5 or negative 5, that will be equal to 150 divided by minus 5, how much? Everyone knows it, right? 30. So it will be negative 30 centimeter. V is equal to negative 30 centimeters. So in the case of concave mirror, we know it, right? The image will be formed in front of the mirror itself. So it will be negative 30 centimeters. So is it clear till now? We got the position of the image or the image distance. Is it clear till now? Give me a thumbs up, everyone. Is it clear till now? Yes. Someone needs help with HI. Yes, we'll solve HI. Don't worry. We'll use the magnification formula. Yes, Sridhya has applied the logic, and Sridhya is saying, sir, the object is kept between C and F. Why? Because the focal length is 10, right? If the focal length is 10, the center of curvature will be at 20. Got it? Now over here is mentioned the object distance is 15. So the object will be between C and F. Object will be between C and F. If the object is between C and F, the nature of the image, we know it, right? Real and inverted. And also the image distance is negative 30 centimeter. So the nature of the image is real and inverted. And the height of the image, even though we know it is enlarged, but still we need to find out the height of the image hi, right? It's not about the size of the image. The question is to find the height of the image. So for that we need to use the mirror formula. Can I rub this? I can, right? Fine. So not with the mirror formula, the magnification formula. So based on the magnification formula, so we can write minus V by U is equal to HI divided by HO. Can we do it? Fine. So what are we doing? We are rearranging this equation. So as to find HI, we can rearrange this equation, right? So HI by HO, if it is equal to minus V by U, can I take this HO to the right hand side? We can do it, right? So minus V by U is equal to not minus V by U, just a second. So as to find HI, we can write, just a second guys. Yeah, so as to find HI is, oh god, fancy colors coming up. HI is equal to minus V by U into HO, or multiplied by HO. So we have all the other values, right? Minus V, U, HO, all values we have based on the question itself. We have the, okay, this is not the question, pardon. So based on the question itself, we have the image distance, we have the object distance. So, and based on the question itself, we have the object distance and the height of the object, and we have found out the value of image distance. So these three values we can apply in the equation directly. Got it? Now HI is equal to minus of V. Minus of V means minus of, how much is the value we got? We got it as minus 30, right? So we got it as minus 30 minus of minus 30 divided by U. How much is the value of U? We got it from the question itself, negative 15. So minus of minus 30 divided by negative 15 into HO. How much is HO? It is given the question itself. HO is 6 centimeters. We are taking this value. So we are multiplying it with HO 6. So minus of minus 30 divided by minus 15 into 6. So minus of minus 30 means plus 30. Plus 30 divided by minus 15 into 6. Got it? So guys, can we simplify 30 minus 15? Can we do it? We can do it, right? So the HI is equal to 30 by minus 15. We can easily simplify it. We can write as minus 2 into 6. Can we do it? We can do it, right? So minus 2 into 6 means minus 12 centimeter. That is the height of the image. How many of you got this answer or value? How many of you got the answer? Wave your hands to the camera. Those who got the answer, wave your hands to the camera. Wave it. Everyone got the perfect answer. You got the image distance as minus 12, and you not the image distance, height of the image as minus 12, and the image distance as minus 30. Fine, everyone is waving. Sir, we got the right answer. Fine. So we got the perfect answer. Fine. So clear, right? Everyone clear with the concept? Clear with this problem? Fine. So forgot to lower your hands, ream shake, or you have a doubt. Those who waved or those who raised hands to say, sir, I know it, you can lower it now, or else I'll assume you have a doubt. No, right? Ream shake, clear this problem? Fine. So guys, before we wind up, okay, this question will be easy for you. State the relation between object distance, image distance, and focal length of a convex or a concave mirror. You know this already. You know the answer, right? It is just the, it's just what? It's just the indirect question for mirror equation, right? So this question is also a homework, and this question is the homework. So guys, we have very less time for the exam time. So what you have to do, take a screenshot of both the questions. So first questions, take a screenshot. I won't be giving you time to write. Once you're done with the session, write it down in your notebook. Got it? Fine. Everyone done? Fine. So next question, take a screenshot. Later on, once we are done with the session, write it down in your notebook. In the next session, don't say, sir, I didn't write the question, I have the screenshot. No. You should have it written in your notebook. Yes, exam is there. Some of you are asking, sir, exam time, let's go. Don't waste time. Who wants the previous slide? Take a screenshot, guys. I won't be giving you time to write. Let's go ahead. So this question is a homework. And the relation between the focal length, the image distance and the object distance of a concave or a convex mirror, you know it. The mirror formula. Fine. So let's go ahead with the exam time. So guys, go for it. Easy 5 question. Try to solve it real quick. Once you're done with it, please do let me know. Those who are done with the exam, type down in the chat box. Everyone done or what? Quick, real quick. You just have 5 minutes of time. You can apply the image formation concepts. You can apply the formula. Someone is asking link for the exam. We are not using Google Form link, guys. When you log in using your roll number and password, you'll have 2 tabs, right? 2 tabs. One to log in and another just below that to log in with the Zoom link. Just below that you will have a tab for exam. So if you are in the Zoom application, don't leave the meeting. Just minimize Zoom application or go back from the Zoom meeting. So that you'll have an exam tab just below the login link. Got it? So please forward it to the coordinators team, Judy ma'am, Mahira, Shaz. Some concerns coming up in the chat box. So guys, you'll have a tab for exam. Which tab? You'll have such boxes. One for the link and another for the exams. So using this link, you will be logging into Zoom application. You will be in the meeting. When you go back from the meeting, in your login interface itself, 90 plus My Tuition app login interface itself, you will get the exam tab. So when you click on the scheduled exam, you will be able to submit your responses as well. Haripriya, please share it. Haripriya has an issue, Judy ma'am. Haripriya, when you go back from the Zoom app, 2 tabs, link and exam. So click on the exam tab and we will get it. Some of you is sharing, sir, I got it now. If you are new guys, please do remember the 90 plus My Tuition app hybrid live tuition login page. You'll have to enter your roll number and password when you log in. You'll have 2 different tabs, right? One to enter the meeting and the other one for the exam. So you'll have 2 tabs. Done everyone? Can we go ahead with the questions? Fine. So first question is, which statement is true for the reflection of light? Angle of incidence and reflection are equal for all regular reflection. It will be equal for all regular reflections, right? Based on the laws of reflection, we know it. Since we understood the first one is the right statement, we know it. So the first option is the right answer. We don't have to read the remaining, right? Reflected light is less bright than the incident light. It can be the other way as well. The sum of the angle of incidence and reflection is always greater than 90 degrees. Not possible. Beams of incident light after reflection diverge at unequal angles. Not possible. So the first statement is the right answer. The angle of incidence and reflection are equal for all regular reflection. Now, the focal length of a plane mirror is 0 infinite minus 25 plus 25. Guys, if you are in front of a plane mirror, even if you change the distance or even if you are looking at the mirror, that is what we say 100 meters away, you'll be there in the mirror, right? Very point sized. So the focal length will not be a finite value, it will be infinite or infinite. So the second option is the right answer. Got it? Now, where will we get the image for the ray diagram of a concave mirror shown here? Where will we get the image? So the object is kept beyond C. Object is kept beyond C. So in the case of concave mirror, we have learned if the object is kept beyond C, where will we get the image? Portion of the image will be between C and F. So the image will be formed between C and F. So don't forget this. So the third option is the right answer. The image is formed between C and F. Now, an object is placed at a distance of 40 centimeters in front of a concave mirror, Rahul sir, concave mirror of a focal length of 20 centimeters. The image produced is virtual and inverted, real and erect, real inverted and of the opposite size as that of the object, real inverted and of the same size as that of the object. Guys, what do you think? So in this question, you have to apply your logic. The object is placed at a distance of 40 centimeter in front of a concave mirror. So we are considering a concave mirror. The object is placed at 40 centimeters. Now the focal length is given, it is at 20 centimeters. Focal length is at 20 centimeters. 20. This is the position where we'll have F. And if the object is at 40 centimeter, you know it. C is 2F, right? That is the center of curvature is 2F. So if the focal length is 20, the center of curvature will be at 40. Center of curvature will be at 40. So 20 plus 20 will be 40. So over here we'll have C, right? C. So the object is kept at C. Now that is the app. We have to log in with the hybrid live tuition login Haripriya. You're showing the app. You will have a roll number and password to log in with 90 plus hybrid live tuition. That is a different interface. Fine. So please do contact the admin team Haripriya. They'll give a clarity regarding this. Fine. So over here, guys, if the focal length is 20 and the object is kept at 40, where will we have the object? Where will we have the object? Who will answer? Quick, real quick. We're already running out of time. Unmute Fatima on top, Fatima Jumana on left side. Yes. Fatima Jumana, unmute yourself. Where will we have the object?
It will be on the far side because our center of the curvature, right? From we learned that it will be on the same side and the size will be same.
So where will we have the object? The object will be
At the center
at the center
of curvature.
of curvature or C. So based on the image formation, we have learned if the object is at C, where will we get the image? At C itself. Will it be the real and inverted? It will be real and inverted, right? What about the size? It will be the same size. So do we have an option like that? Real? Yes, very good. Thank you, Fatima Jumana. The nature of the image will be real and inverted. The size will be same as that of the object. So the fourth option is the right answer. Got it? Fine. Now the next question. Image formed by a convex spherical mirror is virtual, real, 3D image, inverted. For convex spherical mirror means convex mirror. For convex mirror, obviously will not have real and inverted. Always in the case of convex mirror, the image form will be virtual and erect, right? Always in the case of convex mirror. So please don't forget it. Case of convex mirror, always virtual and erect. So the first option is the right answer. Image formed by a convex mirror will be virtual, not real, not 3D image, not inverted. Got it? So the first option is the right answer. Clear for everyone? Any doubts? Any queries? Got 10 on 10. Some of you are sharing, sir. I got 10 on 10. Yes, Sridhya, unmute. Yes, Sridhya. For the second question, it is infinity.
Sir, for the first question, so that it's a concave mirror, right?
For the first question,
First question means not this one, the starting of the this class. One question I did, right?
Okay, you're
I
asking about the first question which we have solved this, right? This one.
Yes, sir.
This concave
I
mirror.
said, but then, why is it concave? Why can't it be like convex?
Why can't it be convex?
Yeah.
Okay, so a student wants to project the image of a candle flame in front of a candle flame on a screen 60 centimeter in front of a mirror, and the distance of the object keeping the flame at a distance of 15 centimeter. Now, over here, if the object and the image is at the same side, which one? Which mirror will have the object and the image in the same side? Concave mirror, right? But for convex mirror, object will be in front of the mirror and the image is behind the mirror. Do you remember in the case of convex mirror, always the image is formed behind the mirror? Got it? So the object will be in front and the image will be behind. But in the case of concave mirror, always the object and the image will be in front of the mirror, except one single case. Got it? Sridhya, unmute Sridhya. Since in the question it is mentioned the object and the image is in front of the mirror, we can consider the type of mirror as concave itself. Clear?
Yes.
Sridhya, clear?
Yes, sir. I didn't read the question.
You didn't read the question.
No, I was like reading, but then you ended the question, so we was going for the other one.
Yeah.
That I only joined.
Okay, fine. Got it.
Thanks.
Yeah. So, any doubt, guys? Anyone else before we wind up? I know the time is up. I'm aware of it. Fine. Any doubts before we wind up? No, right? So, if all the concepts which we learned today is clear, give me a double thumbs up. Yes, Mohammed Nooreen, you have a doubt or you forgot to lower your hands? Mohammed Noorul, forgot to lower, right?
Sir, I have a doubt in the exam.
Okay, exam question. Which question?
Sir, I think it was the one with 40 and 20 centimeters.
This one?
Yeah.
Yes.
So it has to be opposite size, right? Because it will be minus, according to like the sign convention, it will be minus, right? So it will be
Yeah.
opposite size.
Minus. Okay, you are saying in the question it is 40 and 20, so it will not be negative, it will come in the other side.
No, it's like it will be negative on each side, but like the size will be opposite of the size, right? Not the same size exactly. Just minus.
It will be opposite, it will be minus. Okay, you are saying in the case of a concave mirror, the object will be like this, the image will be like this, so it will be negative, right? Are you talking about that?
Yeah, so it will be opposite size, right?
Yes, opposite side, opposite negative value. So that is why it is inverted. For inverted image, we will have negative. Got it?
Size will be opposite.
Size will be opposite for sure, negative.
Yeah, so it's the same size there. So it should be opposite size.
Okay, we can't say opposite size. That is the same size means it is the same size as of the object. For example, if you have the size of the object as 10 centimeter, that is the height of it. Size means the height of the object and the height of the image. So we'll have 10 centimeter and 10 centimeter. It's just that the sign will change since it is inverted. But the distance value of the height or the numerical value of the height will be the same, right? That is the same size. Do you remember? If we keep the object at C, do you remember the image formation of concave mirror?
Yeah, so it will be same.
Same size. So that is why the fourth option is the right answer. Is it clear now?
Yes.
Fine. So anyone else? No, right? Guys, please don't forget, in today's session, many of you didn't revise the concepts which we learned in the previous session. So it is important. We are almost done with the reflection. Only a few more problems, numericals left. So that is why I am not stressing much. That's why I'm like, okay, I hope everyone knows it. I'm not asking direct questions. The next session I'll be asking questions. Everyone do revise all the concepts. I hope you'll do. You'll do, right? Everyone will revise everything. Give me a thumbs up. Fine. That's all for today. Stay happy. Stay healthy. Yes, some of you are sharing. Thank you, sir. Bye bye. Yes, bye bye. Bye bye. Thank you.